So this video is going to be an introduction to CODAP and doing some very basic graphs on CODAP. So if you're on My Open Math at the top of lesson 2, there'll be a link to CODAP right near the top. I'll just show you super quickly if you're in stats. So click on your class, go to the beginning of Unit 1, Lesson 2, and then there's a link to CODAP right here. There should be other links sporadically hidden, but so this is CODAP. We're going to launch into CODAP, and I'm going to start by showing you how to upload a file, and then we're actually going to play around with a different file. So first we're going to just say create new document, which will open up a place for us to drop a CSV. It has to be a CSV file, comma, separated values. So not just any Excel. So I'm going to go to my stats class and I've got some data sets here. You will probably be playing around with the Tour de France one. So if you download that data file, it should be a CSV as opposed to Excel. So it's not an Excel worksheet. It's a comma separated values file. That's what CODAP will require. So then you can just drag and drop your file onto CODAP and it'll turn it into a little spreadsheet on CODAP. Kind of nice user interface. You can scroll it out and you can now see the different variables that were recorded. So there's different years of the Tour de France in this case, from 1903 all the way up to 2015. It's got the winner, country, age, their team, their total time represented in hours, minutes, seconds, total time just in hours, average speed in miles per hour, stages, the distance that they've ridden, starting riders and finishing riders. So there's just an example of opening up a data set in CODAP to play around with. I'm going to just delete this table and I'm going to actually say I want to open a new document so that I can open up this roller coasters example, which is another file, but I don't want to do everything with the data set that you're going to be playing around with. So I'm going to open up this roller coasters file and we're going to talk about making some graphs. I really don't care about this indexing stuff over here. Really all I care about is the roller coaster information. So here is a list of the coaster names, the park that the roller coaster is at, top speed in miles per hour, max height in feet, the drop. You can see if you hover over it, it describes the different variables. If you ever need to like rename, so if you are wanting to make sure that your axes are labeled, so say this duration didn't have seconds, you can always click on the title and hit rename. So I can delete that and then this was duration. And then I'm going to put feet back in. It already had it, but look at that. It now has duration feet twice. So you could rename it to make sure that it has units if you ever need to include units on your axes. So I'm going to show you the very basics of making a graph. So you're going to come over here and we're going to just hit graph. So what this has done is now basically added a dot for every single roller coaster. So it's recognizing all of our values over here as a dot, but none of them have any sort of organization. Right? So I could click on one, it would highlight that piece of data over here, but everything's kind of scattered because it's not organized yet. So the first thing we want to do is just make a very simple bar graph. And if we're going to make a bar graph with qualitative data, a bar graph and a histogram are very similar, except for histograms have a continuous spectrum of numbers along the horizontal axis, and a bar graph is going to have spaces between them because they're different sort of categories. So we will be asked to make qualitative bar graphs. So some of our options for qualitative data are just the type of the roller coaster, steel versus wooden, the design, sit down, stand up, inverted, the age group, whether or not it has an inversion, the city, the park. And we want to make sure that we choose a variable that's going to not only be interesting, but also not be too overwhelming. If I tried to just put the name of the roller coaster down here, so this is how you can put one of your variables on one of your axes, is simply click, drag, and drop. So if I were to select roller coaster and then make this really, really wide, yeah, technically this could be a bar graph. At this point, it's not a bar graph, it's just a dot plot. So it's just got a bunch of dots. But every single dot is pretty much going to just have one entry. It looks like a couple might have two, meaning there's probably two roller coasters with the same name. So this would technically, we could make this into a bar graph, but you can see that this other category is huge. There's just too much information. There's too many different variables that this would not be a good one for us to choose. If you do choose something like this, you'll probably lose points for your graph, because in order to make it so that you don't have a giant other column, you'd have to make this incredibly wide. It's going to make it very difficult to read. And that's going to be part of your grade is, can we look at the graph? You're going to type up some couple sentences worth of analyses, patterns, something that you notice about the data. And it's going to be very difficult to check your work if we have something like this. So let's add a different graph. Something that you can note, you could click and drag. You could also click on the attributes, and I can hover over. There's the state, which is that indexing that I don't want to worry about. But I also go here to different variables from the roller coaster itself. So let's do the park. Let's see how many options we have for park. Still seems like quite a bit. So I do scroll it over. Yeah, it's still like it's better. This one might be all right if I keep scrolling. Now I've got every single one of them. Again, this is technically not a bar graph yet. It is a dot graph, and you can the thing that's missing is our counts over here. So some things that we can note is if you're playing around with the sizing, it kind of updates everything for you, which is nice. If you click on this, you can hide certain cases. So if I've got like an outlier ever and I don't want to look at, I don't want to include it, you could click on some cases. You could click on cases over here. They're going to be highlighted. And then you could say, I want to hide them or unhide them if you wanted to see all of them. I don't want to do that right now. But we want to say add a show the count. So instead of just having the dots and we have to count them, you click on count. It gives us a count along the top. Still technically not a frequency graph because we don't have the frequency over on this axis, but this can help make it easier to read these values. We could do a percentage instead. So get rid of the count. Those percentages are really small and can't really see those values, but they are there. I'll show you that in a second on a different one where we don't have so many variables at the bottom. Right below that, configure the display differently. We want to turn this into a bar graph. So we're just going to fuse the dots into bars, and this is what will turn it into a bar graph. So just give it a second. Boom. Now it's an official bar graph. Here's our count. Over on the left, that's the frequency column. Our other variables, right? The park in which the roller coaster lives is along the bottom. If I wanted to make this a relative frequency, I could click percentage, and now I've got percentages instead of the total counts. I'm going to change this park to being, so you can just remove it straight up, and it'll be gone. I'm going to do the type. So now I can see wooden, steel, maybe not the most interesting. We can fuse dots into bars, but now I can see the count. And if I turn on the percentages, here's 34%, 66%. Another thing that you can do, because this is not a very interesting bar graph, to be honest, it's just saying, well, 34% of roller coasters are wooden, 66% roughly are steel, but maybe we want to look at another attribute, like how old the roller coasters are. So what I can do is click on the roller coaster, or sorry, on that age group variable, drag it over the main part here. And now I can see that not only do I have them broken into wooden and steel, I can also see that, oh, 11.7% are older, 54.4 are recent, 34% of the steel are new. So we can get another further breakdown. We can remove that if we don't want it to be there. Maybe we want to know how many of these have inversions. Like hover inversions over and see that, oh, look, there's only one wooden down there that has a inversion. Mostly the steel ones have inversion. All right, so you can kind of play around with this, but that's how you're going to make a bar graph. If we wanted to make a histogram, going to be very, very similar. We're again going to open up a graph. The only difference is instead of having a qualitative piece of data, we are going to take a quantitative piece of data. So we could choose top speed, max height, the drop, the duration. I'm just going to pick the drop. I can drag it down to this axis. I can make this a little bigger. Maybe I don't need it so tall. We can now see the drop. This is again a dot plot. So if I want to turn it into a histogram, just like before, we're going to click on configure the display. And we're going to say group into bins in this case. So now I've got my bins. So what that has done is broken all of my pieces of data. So they each had a dot for their specific point. Now it's grouped them into bins. In this case, bins that are 50 have a width of 50, 0 to 50, 50 to 100. If I wanted to change that, maybe I wanted to make it 20. It's going to give me a lot more categories. We can play around with that as well. But then I want to fuse the dots into bars to really turn it into a histogram. Now this is a histogram. Again, you can see the count appears on the sides. If I wanted to add a count, oh, I thought it would do it for each category, but you can kind of hover over the data here. And I can see 14 live right there, which is about 9%. 10 are in between 200 and 220, and that's 6.5%. So you can pull some different data. I can talk about the shape. It looks like it's got a peak, roughly between 50 and 150, kind of skewed off to the right. There's some data out there, but not a lot. Maybe we could test and see if this piece of data is an outlier. Different options that we could have. And again, if we wanted to, we could throw on like the type of the roller coaster, and we could look at not only the drop, but then we could see, oh, look, the steel roller coasters seem to have the biggest drop. The wooden ones are mostly down here. There's maybe one or two wooden roller coasters that actually have a really big 200-foot drop. We can remove that. An important thing to note at this stage is since we're making bar graphs and frequency histograms, we don't need to add a second variable over here. Students sometimes, when this is not fused into bars, they want to add an additional variable over here, which is going to create a scatter plot. So we don't need to make a scatter plot. However, one of your other options is going to be to make a time series graph. In a time series graph, it is essentially a scatter plot, but one of our axes is going to be the variable of time. So in this instance, the only variable that we can really use as time, and when I say time, this is like recorded increments as time goes by. We're not talking about like how long it takes for someone to complete a task, and that has to be this axis. We're talking about the amount of time that has passed since some starting point. So if it's years, for example, I'm going to use the years here for the roller coasters. If it were how much time it took to complete a task where t equals 0 is the first start, and then we're recording data at certain intervals, there's another example. But if we're recording like how long does it take all of my individual pieces of data to complete a task, then that would not necessarily be a time series. So in this example, we're going to just use year opened. That's really the only one that makes sense to use as a time series because that time is consistent. And now I do need to add a second variable. The purpose of a time series is we're looking at the patterns over time. So you can kind of see that the number of roller coasters is increasing if you wanted to just do a simple count, a frequency count. But I think it's more interesting if we add something like, let's see if roller coasters have been getting faster, for example. So I'm going to add top speed over here. And we can see that, they were kind of consistent, and it just kind of has a huge range. Like the number of roller coasters we can talk about exploding between, maybe right about 1990 to 2000. And there's not as many, and the spread got a lot bigger. So huge, there's a roller coaster going 120 miles an hour. Or maybe we say, that's not as interesting as we thought. Let's remove the top speed. Let's just look at the duration. Maybe have they gotten longer over time? Nope, again, just sort of more spread. Max height. I'm just kind of looking for different patterns. Anything that seems, this one almost looks exponential. It kind of levels off. Nothing had that big of a drop. And then by the time we got to the 1980s, 1990s, they really went for a maximum height of an increase. So these are the kinds of things we're looking at, just looking at little patterns for time series. Those are the three types of graphs that you will be asked to make, or choosing from those three different types, depending on what class you're in. And I will make another video on how to make box plots, and then I will make another video on how to make linear regression, like correlation equations when we have two different quantitative variables. Hopefully that made sense. Let me know if you've got any questions, and good luck making your graphs on CODAP.